Thank you, everybody, for joining us today. My name is Janet Lee Sheriff. I am the CEO of Golden Predator and the president of Group 11 Technologies. With me today, I have a technical panel of some amazing people that are part of our company. And very briefly, before they start, I would like to introduce Colin Kraft, who is the operations manager for Golden Predator. And he operated the secondary recovery unit that we will discuss in the presentation. After Colin speaks, Hanif Jafari will speak. He is the Chief Technical Officer of EnviroLeach Technologies, which holds the patent for an environmentally friendly solution that is utilized to extract gold. And finally, we'll wrap up with Mark Paliza. Mark is a 40-year veteran from the uranium industry and has worked extensively with permitting and operations. So I will moderate the session and I'll give a brief introduction to begin with. Group 11, if you're not familiar, is actually the section of the periodic table which covers gold, silver, and copper. And the company formed out of some work that we did at Golden Predator up in the Yukon. And before I get into this, I would like to say Dendao, which is a traditional Kaska greeting, and thank the Kaska Nation for allowing us the opportunity to do this amazing work in their traditional territory. None of this would have been possible without their support, and also without Colin, who really started everything off for us. We're a private US company, and we're committed to the development and application of environmentally and socially responsible precious metals extraction. We've combined a non-invasive extraction technology known as ISR, or in situ recovery, with environmentally friendly processes from EnviroLeach Technologies to provide an alternate solution to conventional open pit mining and underground mineral extraction. Our goal is to address mounting concerns that face the industry to be more socially and environmentally responsible. And the company is owned and operated by three partners: Golden Predator Mining Corp, EnviroLeach Technologies, and Encore Energy. Encore Energy are the pioneers and patent holders of the original technology as it applied in the uranium space. EnviroLeach has been working extensively and diligently on this new technology. And this marriage of these two technologies really came about because we had an opportunity to try something new at Golden Predator in the Southeast Yukon. And Colin was instrumental in that. We're now supported by a staff of scientists, some extensive data, and I won't belabor it. I'll allow the others to speak. I'm going to just briefly go through really everything has a point where change is imminent. Computers evolved, medicine evolved, and now precious metals extraction is evolving into the future. And before we start, I'm just going to play a brief video just to give you a high-level overview.
When you think of the metals we use in everyday life, you probably think of traditional mining, something like this. Or maybe this. You probably don't think of this. This is in situ recovery, the most well-known form of in-place metal extraction. It is the future of metal production. How does it work? A solution is pumped into the ground where it selectively dissolves the target minerals. Then, the mineral-rich solution is drawn up extraction wells to a water treatment plant. Minerals are removed from the solution, and the solution is recycled through the system. When the process is complete, reclamation is greatly simplified. In situ recovery techniques are currently being used in several sectors, including uranium and copper, in locations around the world, with lower costs and significantly reduced environmental impacts. The Group 11 Technologies team includes inventors, innovators, and pioneers from the earliest stages of ISR. The latest breakthrough is an environmentally friendly solvent made entirely of food-grade materials. Group 11 is working to revolutionize traditional concepts of gold, silver, and other metal production, moving towards a future that is safe, sustainable, and economically viable.
I'm hoping that gives a bit of an overview before we start into our discussion. I can't stress the importance of having a strong team, a multidisciplinary team in order to go where we're going, to really try and create some substantive and meaningful change in the sector that really helps advance projects and deals with social issues. Colin Kraft is the first person that's going to speak. None of this would have happened without having him at the plant in Watson Lake, Yukon. Golden Predator made a decision to do our own processing. It was a first. Everything before that in the Yukon had been shipped out. Gave us a strong metallurgical understanding. And when we did send some material to a smelter, we were able to see that the gold-silver ratio didn't match. And then along came Colin, and what we did with a secondary recovery unit in order to extract the gold. And Colin, I'll let you speak to how that worked under your leadership.
Okay, sounds good. So anyway, as Janet had mentioned, I'm operations manager with Golden Predator, and I've been working on the bulk sample plant that we built in Watson Lake over the last 4 years to build it and run it. The plant produced two products. One was a high grade gravity concentrate that we were able to pour directly into a bar, but it also produced a secondary mid-links product that needed further processing. And as Janet had mentioned, the first batch we sent off to a refinery way down in the U.S. and we didn't like our returns on that one. So that sort of bore the idea that we would go with a self-contained leach unit to process this material. And we started building that with the idea to use cyanide. And after much hassle trying to meet all the regulatory requirements, the opportunity came up to try to move forward with the EnviroLeach solution, and this we did.
So Colin,
Yeah.
So the first thing we did was we sent off a sample to the EnviroLeach lab, correct, in Vancouver?
Yes.
Okay, and how did that work?
Offhand, I can't remember the exact results, but it showed promising results, and that led us to try the process in our SRU.
And I understand that we had somebody that our metallurgist was able to go to the EnviroLeach lab and witness the whole process. You know, because we did get a lot of is this a little black box? Is this really going to work? And my understanding was they were very open to the concept of having the whole process witnessed.
Yeah, Robin Fraser went down and visited with Hanif and the rest of the folks at EnviroLeach and witnessed the first leach of our mid-links material, and we moved forward from there quite quickly.
And then Hanif came out to site to witness the whole thing. This was the first in the world field test of their solution, and I believe stayed out at site with you and ran through the whole process.
He did for three of the runs, I believe. We've done a total of 12 different batches now.
And the recovery is as good or better than cyanide?
Yeah, well, that's what I was going to say. When comparing it to cyanide, which I've used in a number of different operations, in a number of different forms. I've done CIP, CIL, Merrill-Crowe, and to compare it to cyanide, as far as recoveries and time, quite similar. Most of our tests have showed in the mid to high 90s on recovery, and the leaching, majority of it seems to take place in about 6 hours. Just to get some of the coarser material, I've typically run it for 20 hours. So in that respect, very similar to cyanide.
Okay.
It has a few advantages in other ways. Much better as far as, you know, being environmentally friendly, and operational friendly. Having the neutral pH is a big thing. With cyanide, you're always dealing with a very high pH. Make things a little sticky.
That's a nice way of putting it.
Yeah. And the other thing is the process is actually even simpler than cyanidation typically, because in cyanidation you usually end up having to absorb your gold from the solution onto carbon, then strip the carbon before you can recover it with the electrowinning. We skip all those steps. It goes leach to solution, filter the solids out, and directly to electrowinning. So it makes it very simple.
Excellent. And safety, employee safety?
But yeah, I was saying operationally, it makes it much better as well. You know, it's a food grade additive, so FDA approved, safe in light doses. Like everything, too much of anything isn't good, but quite safe. The difference between the regulatory requirements for this versus cyanide are huge, and the other advantage is the solution's reusable, whereas cyanide there usually has to be some bleed off.
So would it be a fair statement to say that all of the gold that you were able to process from the plant is green gold?
Absolutely. I mean, the plant itself was gravity, no chemicals, and then the leaching itself was done all self-contained. So
Okay, excellent.
green
Well,
as gold as I ever made.
Well, thank you, Colin. You have a vast amount of experience in the industry in gold, tungsten, everything. So we were very fortunate to have you at the plant. And I'd like to ask Hanif to speak now. Hanif, as the Chief Technical Officer of EnviroLeach, you have a lab in Vancouver. And maybe talk a little bit. I know we get a lot of questions about what's going on with your formula, and it's not our place to answer. So I wanted to give you a chance to speak to that.
Hi, everybody. As Janet mentioned, EnviroLeach Technologies is engaged in development of the environmentally friendly technology to extract precious metals, especially gold, from primary and secondary sources. By primary, I mean conventional mining from open pit or underground mining operations. And by secondary, I mean like what we call urban mining, all the recycling of precious metals from secondary sources like electronics and etc. EnviroLeach formula is a patented formula. The formula is a water-based, cyanide-free formula which operates in neutral pH, ambient temperature and pressure. very safe to handle and storage, and also regarding the kinetics, leach kinetics is very comparable to cyanide. In most cases, are faster than cyanide. Regarding the cost, is very comparable to cyanide simply because it's recyclable. Where in cyanide, in base cases, we can recycle 15% of the cyanide and reuse it. And regarding EnviroLeach, it's 100% recyclable. There is lots of advantages like simplified permitting, no tailing pond monitoring, and no destruction cost. Where in cyanide you have this destruction cost, and it's more socially acceptable environment because it's simply environmentally friendly. All the ingredients are safe for human consumption.
And employee safety.
Yes, it's completely safe, and all the operators and people at Golden Predator were surprised that it's what the difference between cyanide, because they've been very familiar with cyanide process, and to observe the difference between cyanide and our technology.
Now, one of the things I wanted to ask Hanif was, I think this breakthrough that you've made in recycling the solution is really a game changer for you and for us. That to me, I think is quite exciting. Did you want to elaborate at all on the recycling component?
That's true, because as you may all know, sodium cyanide is a very cheap chemical, and that was the challenge in the industry, that one of the key factors that an alternative to cyanide needs to have is a cost-effective factor comparing to cyanide. And so far, there was no alternative to cover that challenge. And what we did, yes, our chemical is more expensive than sodium cyanide. And what we could do to reduce the operating cost of the process is to recycle the solution and reuse it over and over.
Mm-hmm.
And that brings the cost very comparable to cyanide, and plus it has no destruction cost.
Yeah, then you add on the timelines and the costs of permitting and reclamation, and
that's all on top of that. Yes.
Yeah, a game changer. Hanif and Colin, one of the things that that came up as questions were things around, is this just refining, or is this really processing? And my take on it was it's not refining. We were processing, and this is something that we can look at application in other ways other than simply on a sulfide. Colin?
Yeah, it's processing. Absolutely.
Okay. Yeah, and Hanif, you are using this technology in e-waste at EnviroLeach, correct?
Yes.
Okay.
We've been using on e-waste to extract precious metals on e-waste. As everybody knows, e-waste has a significant amount of precious metals in it, from gold, silver, platinum, palladium, and other precious metals and valuable metals. And yes, it's a processing of material. We did thousands of tests and assays on different type of materials from deposits all around the world, different type, oxide, sulfide, and even carbonaceous material.
Yeah.
And all the results were really promising, and we were able to get very high recoveries, very comparable or even higher than cyanide in most cases.
And when we finished this work, it really led to a discussion about application of this environmentally friendly formula and what we did at the secondary recovery unit, and can we apply this on a broader scale in the gold space? And to that, we had a meeting with Mark Paliza and several other directors from the Encore Energy Board, and had a discussion on, can we use a similar technology that's used in the uranium space called in situ recovery to look at extracting gold in a more environmentally friendly, less invasive manner. Mark was at that initial discussion that we had. And Mark, I think if you could just talk a little bit about in situ recovery and its application in the space you come from and how it could be applied to gold. And I acknowledge you've been doing this for 40 years and have worked extensively with the EPA in your industry. And if you just want to talk a little bit about that and how it would work in the gold space. And I also appreciate that about 50% of the uranium industry now in the US is in situ recovery. So it has been a game changer, and as well as changes in the copper industry.
Thank you, Janet. And yes, more than 50% in the U.S. is in situ now, and actually more than 50% of the uranium produced in the world is now produced using in situ recovery, or as I would say, ISR. ISR is an acronym that's generally used in the industry. In situ in Latin means on site or in place. So what that means is, unlike conventional mining, where the mineral and the host rock are evacuated together and brought to the surface and crushed and processed, with ISR, the mineral is removed without removing any of the host rock. So the host rock stays in place. This is done through wells. Wells are used to inject amended groundwater solution into the host rock in place. The solution dissolves the minerals as the water is moved past the mineral, and then it is pumped to the surface with a nearby production well, which sends the water with the minerals in solution, as we call it, the pregnant solution, to the process plant to be recovered. And this cycle continues over and over again with injection and extraction until the desired level of recovery is achieved. So that, in a nutshell, as your video showed, is what in situ is. It's relatively simple in concept. Again, as you've mentioned in the video, there are advantages of in situ, environmental advantages. There's significantly less surface disturbance. There are no mine pits, waste dumps, haul roads, tailings ponds. None of that is needed in the in situ process. In situ requires much less water because, like open pits and shafts often require dewatering, you do not need to dewater the formation with in situ recovery. There's minimal heavy equipment used. There are no haul roads, waste dumps, etc. So air quality degradation is much, much less with in situ. There are fewer employees with in situ recovery. So thereby transportation and socioeconomic concerns are reduced. And finally, the creation of large excavations and surface disturbance allows for the surrounding land to be used for traditional uses. So that's a good list of advantages to in situ. Now, if it's so simple and has all of these advantages. What else is needed? Well, it's important that the deposit that is being subject to in situ recovery, whether it's uranium or whether it's gold or whether it's another mineral, is amenable to the process. Um, Again, some of these things sound obvious. The solution must be able to contact the mineral in the host rock. That seems obvious. The mineral must be a species that is soluble with a specific solution. There must be adequate solution control with ISR. The formation geometry must prevent the solution from migrating away from the mineral. Typically, low permeability layers confine the mineralized zone. As such, these deposits should be evaluated by qualified geological engineering professionals for ore quality, ISR amenability, and project economics. In doing this, we often will take core material, do bench testing in the lab, and test for amenability before the project is ever started. So again, it's in situ recovery is a proven technology. It's certainly proven its worth in the uranium recovery business and in copper. The environmental advantages are great, but it's important to have a qualified group looking at every property individually for amenability before you begin. So that's my 5-minute nutshell, Janet, and I
Thanks,
hope
Mark.
that helps.
One question I have, Mark, is when this technology started in the uranium space about 40 years ago, buy-in from the industry, application, how did it work? Because it's hard to believe that it could work in your sector, right?
Well, I've been in the business long enough ago where I was called a baby miner. Of course, I was a baby back then, but we were in certain states in the United States that have not had in situ. It's still there hasn't been a lot of in situ developed. Why? Because the conventional mining industry did not accept in situ. In situ started in South Texas some 50 years ago and Wyoming. It started with small operations that were not large enough to support a full-scale conventional mine, and hence we were called baby miners. Well, fast forward 50 years, and now there have been some very large in situ operations in the United States. It's the dominant method of producing uranium, and the largest uranium production country in the world, and that's Kazakhstan, produces all of their uranium through in situ. So we've gone from baby miners to predominant miners.
And quite prevalent in Australia as well, I believe, correct?
Australia has very successful in situ recovery operations. Yes.
Excellent. Excellent. Yeah, fair to say what we're doing really is we're trying to create disruptive, innovative technology in the golds and precious metal space, similar to what you did in uranium 40 years ago, and changed the industry, what you did.
That's correct.
Excellent. Well, I want to thank everybody for their input and their contributions to both the panel and what we're doing at Group 11. Now what the company's focused on, we have our own test projects in the US where there's regulations in place for underground injection controls. We'll be going through the processes as Mark described with the lab tests and the simulations. And we're also receiving inquiries from other people in the industry, which is really exciting because they want change and they are appreciative that there's steps being undertaken to look at potential change. Group 11 has also received phone calls and inquiries from several universities in Canada, really curious and interested in what we're doing and how this might apply to any future changes in the Canadian landscape. We look forward to keeping everybody posted on the results, and really appreciative of the Yukon Geological Forum that we've been presented here at Geoscience and able to contribute our technical information that we've gathered. thankful for the time today and welcome all the questions that you would care to put forward to our group. Thank you again to the organizers, and thank you, everybody. Thank you, my panel. Appreciate it.